So you can finish your models during the week. As I said, next week you should be able to do a mini-solve, to have all conditions together that the mini-solve, that you see all the financial events happening. And check among yourself if you have problems. And if you have still problems, then you can ask Yannis, but don't ask him too much. Really try to solve first, because he has a lot of work otherwise. So that we should spare him a little bit. Or you can also come next week early, so then you might make the last steps. So here we come back to sensitivity, where we left last time before Easter. So we have to finish the chapter sensitivity, which, one sec, if you see it from that picture, just to have the whole overview. On top, which is not on the picture now, we have the input elements. So input elements is mainly what you're concerned now about. So the basic data, contracts, counterparties, markets, etc., so it's not on the picture. But given those input elements, we do first a mini-solve, we said, and the mini-solve creates exactly that first line up there, the financial events. On the timeline, it will tell you what happens to the contract and what is the significance of that, what happens, and that then will determine what happens below. So that from these events, then we can derive what is the liquidity, what is the value. And if you have value, which we have discussed about 3 lectures back, so then we can go to sensitivity. And sensitivity is nothing else than how is this value going to change if any of the risk factors is going to change. And the risk factors are basically a counterparty, market, and behavior. So if they change, then something changes. And these are the dangerous things, the dangerous things which we have to be careful and to guard ourselves. And that's why we do stress tests and all that if we are in the banking area. Okay, so and today we are in sensitivity. We have started already before, and now we are here. That's where we left last time. This is a complex example from sensitivity, and the first target we have here is to get the interest rate sensitivity. But you will see if we have the interest rate sensitivity, we have almost all others. That's then by implication, because that is also closely related to value. And everything is basically value-driven here. The special thing about this deal is it's a constant maturity swap. So the constant maturity swap has the following feature in this case. It reprices every 3 months, but not on the 3 months rate. That's the difficult part. If you reprice on 3 months, on the 3 months rate, then it's plain vanilla finance. Then you do discounting, everything as you know it. But if you reprice every 3 months on the 6 months rate, you introduce additional risk factors. And that makes the discounting so more complex. And of course, we could have more complex examples than even that. So now we try to figure out how the derivation goes. We went through that already last time, but I was rather fast. So we have a deal that starts right at this point. Actually before 1100. So it's actually we are on 31st 12th at 24:00 at night. Just before the stroke of the bell. So we are there. The deal starts on the first and at 00, just a second after. That's what the deal starts. And it has a first interest payment which is already fixed. So this one here is already fixed. So that's already fixed. Then it will reprice on that date, on the 1st/4, it will reprice again, but on the 6-month rate. So that's the little trick which we have here, which makes it more difficult. So what we need first is a yield curve. That's why RISPRO is always asking you a yield curve. So without yield curve, nothing goes. There's no finance if you don't have yield curves. Huh? So that brings everything on the timeline. So we have the yield curve. And there is a first cash flow going out right a millisecond after the point of analysis. So that, what is the sensitivity of that cash flow? 0. You know, you get your 100 or you pay your 100 and that's it. And that value is not going to change anymore because there's no time in between. So we don't even talk about the first cash flow. So that is given. Sensitivity of this is 0. What is the sensitivity of that second cash flow? That's the first interest payment which is already fixed. So it's on a fixed rate, so the cash flow is really known. So how would you derive the sensitivity of that cash flow? Any clue? What is the general formula of sensitivity? Change of value over change of rates. So you have to think on the rates now. But how does the rate play a role here? Not in the fixing of the cash flow, not anymore. That's already given. This you can take as a constant. So the cash flow doesn't change anymore independent what the interest rates do. So that's given. But then how does interest rates still affect? Via which mechanism does interest rate affect that? We said sensitivity is change of value over change of rate. So how do we get from this cash flow to value? Discounting. So we discount. So, and in discounting, the rate plays again a role. So if the discount rate changes, the value changing. So who has a guess which measure is important for that one here? It's a duration. So whenever, I think, duration, I assume is that the known measure. It's the interest rate sensitivity. It's actually dV over dr. That is duration. That's why it is, and it's 3 months out. How much would you guess the duration to be? 3 months, yeah, it's 0.25 to be exact, because it's in years. It's measured in years, so it's 0.25. If you measure in months, it would be 3 months, but it's not. The months is a little bit not so easy to handle. So we have 0.25. So that's given. So that's an easy one here. So we just take that point. We take the rate. We discount it, and by changing that discounting rate, we get the first derivation, which is the duration. Then, okay, that case is easy. Now we are on this time on the 1st/4, 0, 0. So now we reset the rate, and you see the function up there. It's ft0. T1 and T3 here. Why? So T0 says we are looking at it from here today. Today is T0, but we are repricing on the rate which reaches from T1 to T3, which is the 6 months rate. The T3 will be then first tenth. So these two, they play then a role, and and also the rate of T2 plays a role. Why should the rate of T2 play a role? We are repricing on the 6 months rate. So we are actually reaching out to first tenth and not first seventh. But why does the rate of T2 first seventh still play a role if I look at sensitivity and value? Because the cash flow comes at T2. That's the tricky part of that deal. It's because you create the cash flow in T2, which is a function of T3, T1 and T3 actually. That's why you have all these complications here. And then, so you create that cash flow, which then comes at T2, and then you discount that, and that gives you all the explanation at below. So if you go through this, so this below explanation explains just the derivation of that one cash flow. But I think you have to know these things. You don't have to know it precisely because the machine is doing it for you. But I think it's always better to know these things because they can change the risk drastically. And you can see that here. Look, this thing is repricing in 3 months. It's repricing every 3 months. So the next repricing rate is in 3 months. So what would be normally, say, how long is the duration of this thing? So if you go just a hip shot, you would say it's 3 months. Not because it's repricing in 3 months, it's like a 3-month deal. Okay, the duration must be 3 months. So you would guess on the right picture. That's how the sensitivity gap looks like. So it's repricing in 3 months. But the real sensitivity is the one which you see on the left side, because it's sensitive to all these factors. So you see the risk is very different. So the naive picture on the right is very different to the real picture. So, and then if you do not know that these things can happen, you know, so then you might much easier fall into traps. And even if you are a manager of a bank, so to speak, even if you don't know the exact formulas, you should have the feeling for that. You should have the feeling, you know, something going on, this is really sensitive to that and not sensitive to that. So that is what the kind of feelings you have to develop. Not so much the mathematical. I think it's very good to be mathematical, it helps you. But then you're not fixed to the formulas. You really know how to use it in your decisions here, when you have to hedge, when you have to do this and that. So that's the left picture is the sensitivity of that constant maturity swap, and the right picture would be the naive view of it if it would be a simple 3-month swap which reprices on a 3-month rate. The gap would look like on the right side. Yeah. Now, what we see here is the liquidity gap. The sensitivity gap. And you might remember the liquidity gap. And if you look from a picture viewpoint, it looks the same. But don't be tricked. So it only is the same way of display, but it has a total different content. Here we see on the right side, I see it's the liquidity gap. So the liquidity gap of all the examples which we had in the book, it's the right side. So we're getting liquidity far out. You know, it's going on actually. I only show a few quarters. And then on the left side, we have the interest rate sensitivity gap. So what has happened here? What is the difference here between the two? Can you explain why the liquidity gap looks like the right side and the interest rate sensitivity gap like the left side? What drives liquidity? What drives interest rate sensitivity? So liquidity is driven by the real cash flows, you know, when they come. For example, if you have a variable rate bond which goes 10 years, so you will get cash flows for 10 years, interest rate, and maybe after 10 years you get the principal. But it's now a variable rate bond, say, which reprices after 1 year or so. So what drives the interest rate sensitivity? It's the repricing. So if you have a 10-year bond with a 1-year repricing, from a liquidity viewpoint, it's 10 years, because you get cash flows for 10 years. That's when they pay back. From a sensitivity viewpoint, it's like 1 year. So you always think of what is it sensitive on. So what you have to develop is like an intuitive feeling for first derivations. And you get that if you think about how things are linked. Then you know what influences what, and then you can do the derivation in your belly, even without doing the correct calculation here. Okay, so the difference between here is because we have a lot of repricing, so instruments which reprice early, but which are long-term repricing. So that's why the sensitivity gap is much shorter. It's much more to the present than the liquidity gap. So we get the liquidity late, but it's early sensitive. That's the difference. And if you go through all the examples, then you will see that. And how do we really calculate that? In a very simple form, how do we do that to get to the left picture and the right picture? How would you do it having all the information, let's say in the book up to chapter 10? How would you get the left picture and how would you get the right picture? The left is the interest rate sensitivity and the right is the liquidity. Which numbers would you take? It's these numbers which you have to take. So you have, remember, we called that liquidity, and this we called ZES, because there is no better name for it. And ZES stands for zero coupon equivalent sensitivity. And that's exactly what we do. When we had this here, look at that. These derivations, they made from these contracts, from these facts of sensitivity, they made like little zero coupon bonds out of it. That's how you have to imagine it. So we turn everything into zero coupon bonds. And the zero coupon bonds are comparable. But without the discounting yet, as long as we have the sensitivity over there. And then comes the discounting comes on top of it. But that's basically what we do. So we look onto which rate is the thing sensitive, and given that rate, how much zero coupon bonds should I have to get the same sensitivity? And if you do a first derivation, that's exactly what you get. Because a zero coupon is exactly the duration of a zero coupon bond is its time. So that's the steps which you have to remember. But once this is done, it becomes very easy. So just know these steps. So the zero coupon duration is the easiest because it's described by time. If you know the time, you know the sensitivity. Just multiply it with value and so on, and you have everything. So then you get the results by simply going through all the examples in chapter 8. And if you want to have liquidity, first of all, imagine buckets, time buckets, and sum each of these in the corresponding time bucket. Just put it in the right time bucket. And that's all. The same you do for a zero coupon. And then you get the right expression. Okay, that was interest rate sensitivity, actually. But we will see that once we have interest rate sensitivity, we have also all the others by default. So let's go to FX sensitivity. So we have here, this is the value in base currency. So the value in base currency is the cash flow in its contract currency. Say the cash flow is dollar, but the base currency is Swiss franc. So you have to measure the cash flow in dollars. So you get all the dollars cash flows there, and you discount it using the dollar rate, CC, contract currency. use normal discounting function, like you have it, just multiply by fx. That's the current fx, today's fx, because you have brought everything to today. So now you can apply the current fx. And the sensitivity of that is the change of the book of value in book currency to the change of the fx rate, which turns out to be the value in contract currency. So very simple. So the FX exposure, if you have $5,000, then it's $5,000. Not 4,500 Swiss francs. You have to remember that. And of course, that's just simple for a bond. It's just the value, the market value itself. If it's an option, then you have all the, the deltas and all that playing a role yet. So it's it's all there. But that's how it goes. Okay. Then the stock currency, so that means the stock risk is the change of the stock given a change of the risk factors. So but it's basically the result of it is the beta times the value at time t. So if you have a stock which beta is 1, I mean it's just the index, so then the value of the market value of that is the sensitivity itself. So if it has a beta of 0.7, then it's 0.7 times that market value, which basically gives you the sensitivity of your stock portfolio against that index. So then it's always measured against an index. So, and both numbers can be derived if you know this, the CES column, the zero equivalent sensitivity. So it's by simple addition, adding, discounting yet. Of course, the discounting has to come yet on top of that, but then you get this value. And I mean, this morning you saw the list of all the events. They are driving this thing. So these were all the market risk factors. Beside market risk factors, we have yet credit risk factors. So what is the sensitivity, the credit risk sensitivity? So here we see this is the impaired value, V prime. So V prime is impaired value. Impaired value means the value minus what you expect to lose. Impairment is the losing, the PD. So it's 1 minus PD. PD is the probability of default. So if you have 5% probability of default, so the impaired value is 95 and not 100. If the simple value is 100. So now we do the derivation of this impaired value against PD. And this is value itself. And that is measured, and this value is measured as exposure at default. So it's the net value. You have to be careful. Because let's say you have given somebody a bond, or somebody you have given a loan, and nothing else. And the loan is 100. Then you're exposed 100, obviously, because you can lose 100 when you default, and your exposure is 100. But if the same person has given you a house which has a value of 200, obviously your exposure is 0. Independent what the probability of default does, you don't lose. So that's why you have to measure it with the exposure at default. And that has been described in chapter 5. I think, yeah. But we are coming back to that. So let's measure a current exposure of a counterparty. So we have the value basis fair value, and say the gross exposure is 350,620, like in this example. That means I have an outstanding loan of 360,620 measured on fair value basis. So that depends on interest rates, everything. So there is no netting gain. So that means that's the only outstanding loan I have. There is no liability where I could net. But the person has given 185,300 collaterals, and that is also measured in fair value. So it's fair value, what you're getting there. And then somebody has guaranteed 100,000. So you deduct from the 350, the 185 and the 100, and you're left with 65. So your real exposure is 65. And for those who do this credit risk exposure example, of course, then once you have put the right data, that is the number which should come out. And if you don't get that number, you have somehow made errors in linking the contract. Or you have found an error in the software. That's all. No, that should not be. No, because it's really well tested, these kind of things, because all the banks work with it. But they don't want to have these kind of errors. Okay. From that we have recovery, and so we get a loss given default. So our exposure is 65,320. So should we write down into the books, my risk is 65,320. I could do that. But now we have to be a little bit more careful. So the banks would not, and also regulation, Basel, etc., they would not allow the number to be 65,320. Why not? What could be? Why would? First of all, what is the first guess? Would they like to see a higher number or a lower number? If they are careful, what is your guess? A higher. You know, a high means higher exposure. You know, the higher the number, the more the risk you have. Huh? Okay, first of all, so our assumption is they want to see a higher number. But why would they like to see a higher number than that? Because it's based, and that's important to see here, it's based on fair value. And because it's based on fair value, we have already all the information necessary in our event list. So we will find everything there. Also for credit exposure, you will see, plus some additional information like who owns whom, etc. So it's on fair value. So everything is on fair value. If it's on fair value, what do you expect with this value going to happen in future? What happens to market values? They fluctuate. So now you have to take into account that things could turn against you. You know that due to fluctuation, this value is going to change, and especially to increase. There's a chance that it is increasing. So basically, I have to calculate, say, in a 95% environment or something, percentile, how much could it change? Now, how are we going to do that? Now, always consider you have a good system like RiskPro at your hands, so it's much easier. so it's really at your fingertips. You're right to have to do, just use it. But which technique would you apply if you want to now figure out now how much is this value, can it change? Now here, I mean, you could use stress scenarios, that's one. But here, normally it's better because you want to have like a 95 percentile. So you have to use risk scenarios, meaning, you know, a lot of distribution so that you can do that. And how are we going to do that? That's how you would do that. Let's start with here. So the current exposure, the current gross exposure, the gross exposure means everything outstanding, no collateral. So just what you have given to that person is, we see here, is here. And, but then we have a collateral. So that's the collateral value. So the exposure at default is obviously this here. So that would be like the 65,000 what we saw before, given here. But now we have two things that can change. On one hand, my exposure, the value of the exposure can change as well. And that depends on the sensitivity. If something is very sensitive to something, you know, then the value is going to change a lot. If it's little sensitive, it's going to change a little. So sensitivity plays an important role here. So the exposure can change in value, but not only the exposure can change in value, also the collateral. So both, and in the worst case, they change in the wrong direction. So then it goes in this direction. So that's why, so assume the collateral is going to drop, the gross exposure is going to increase. That's why then your potential exposure will be like that. And that's the number they want to see. Also the regulators, but even you inside the banks. So you want to see the potential exposure. So how much could it go within the next future, given market conditions fluctuate? And the potential gross exposure goes up to here. How we do it? We said we use now simulation technique. So what is going to change the collateral value? Mainly market conditions, and of course it could yet be counterparty conditions like ratings, etc. So if you go into the future, so that's what you could do, and so that could be a potential scenario. Now here, let's say we have a swap. Swap have a tendency to go to 0. If it's an interest rate swap, you know, at maturity date, the thing has a value of 0. Because nothing there. The current exposure we have here, and here I'm just focusing on the exposure. Here. So that's the exposure. And now because market fluctuations can drive up the value up here, it could also go down, so that depends on the scenarios which you have, but the scenarios have to be realistic, of course. So we have a big fluctuation of value. And let's say this is the peak value, and if you take the 95 percentile, it goes somewhere here, and it peaks here. So you say my real exposure is this, or 99 in this case. Or you can express it also simply in this formula if there is a simple relationship. So it's the potential exposure is the exposure at default now, times 1 plus R. R is the percentile, the number for the percentile. The change of the exposure at default, the change of risk factor, times the sigma of the risk factor. That's simple. But then there is some stability assumptions and so built in, but that's going. Now linked to the idea of potential exposure are the terms haircut and add-in. Are you familiar with the terms? Haircut, so don't think on the barber. It's so you have a lot of haircut discussions if it comes to credit risk. Probably you have heard it, you know, haircuts. If you read it even in the newspaper. Yeah? So what is cut here? So which barber is doing this here? And so let's, I start here with add-ons. Haircut will come afterwards. So these two terms are related, actually, add-ons and haircut. So add-ons are actually meant to be adjustment to exposure value. When we go back here, remember, there are two things that fluctuate, your exposure and your collateral. So the add-ons is the thing which changes the exposure. But it's like a pre-calculated, let's say on common knowledge based, because not everybody can make a dynamic simulation, Monte Carlo, and so most banks can't. So they don't have the possibility. So what is there? There is a lot of experience with such possibilities, and there is then rule of thumb values for it. So basically, you make a rule of thumb of that. So if you know, okay, this type of instrument, you have to add so much. This type of instrument, you have to add so much. That's what it is. And this is a classical table here for add-ons. For example, that is for interest rate, FX and gold, equity, precious metals, and so on. And so they look also at the maturity, because this is very maturity sensitive. If you have a long-term swap, of course, that is more sensitive than a short-term swap. So you have to have more capital for a long-term swap than for a short-term swap. So that's the idea behind, and it's very rough. They only have 3 categories, like less than 1 year, 1 to 5, and bigger than 1 year. And if it's an interest rate swap below 1 year, so there's no charge, no additional charge. Here it's a half, and then it's 1.5%. But you see in gold, FX a lot, 7.5%, and other commodities, 15%. So if you have a commodity future for any other commodity except precious metals and gold and equities, so then, and if it's longer than 5 years, you have to add 15%. So to the exposure, which you have. And then the haircuts, I take here the Basel haircuts. You know, there can be different haircuts, but these are the given by the regulator. That's also the formula they ask here. So it has a similar function like add-ons, but it applies on the collateral value. So if you have a collateral, from the collateral you have to deduct, because if that has less value, you have a bigger exposure. And of the add-ons, you have to add on, because it's the exposure. So you have a bigger exposure, a lower collateral, so that makes a bigger exposed value and a bigger capital charge at the end of the day. Because for that, you have to keep capital. On the other hand, we have to be careful a little bit. The language is not always precise. I think some people sometimes mix up haircuts with add-ons. So be a little bit careful. But I think the original meaning is the one which I gave to you. Sometimes I got also confused by different use of that. Yeah, so these have been now the normal banking products. So sensitivities, so we had the market sensitivities, we have now the credit risk sensitivity. Here, now we come to a few others just for the completion. For example, in the insurance sector. So there, in insurance, mortality plays an important role. So they might check for mortality sensitivity. It's a little bit brutal, but that's how insurance people have to think. Really? So you see, how much is my value sensitive on mortality? So you see it here. The pi is the premium you pay. So somebody, and this is a 1 year life insurance, one shot. So you make an insurance for 1 year and for 1 year only. So you pay pi for that. S is what you get when you die, the payoff. And Q is the probability that you die here. And the value of that is discounted using normal discounting technique here. So then if you take the first derivation against that, then you will see it's the discounted value of the payment, which is the sensitivity. You get that there, the S times. So that's how you calculate sensitivity to mortality. So that's about, and there are other sensitivities, especially there are then the sensitivity against behavioral factors. And how do we calculate sensitivities against behavioral factors? Is there a formula? Who knows the formula? Nobody, because it's unclear what behavioral factors are. So you have to find out. So basically, if it's behavior, if you do sensitivity, you do it with stress. You take a behavior, you shock the behavior, and calculate the effect of whatever you want. And if you do a 1 unit shock, then you have exactly the sensitivity. If it's a 2 unit or 3 unit shock, then you have to divide by the units you have to be shocking. So that's against our risk factors. So that closes basically what sensitivity is. But sensitivities can be used also not only for this type of calculations, which will then play an important role in risk calculation. We will see that when we do the next step. So there it will be completed. But even before we do risk calculations with sensitivities, sensitivities are also used for something else. We see it here for limits. So many traders, they have sensitivity limits. So limits you can define in different ways. like on value, on stop loss, or something like that. And the one way of doing it is sensitivity. So why should you choose sensitivity? Because that's like a first measure of risk. So if you're highly exposed to something, obviously it's a risky case. Of course, we don't know yet the volatility of it. That's missing yet. But the sensitivity in itself is already very, very good. So that's why we talk about limits here, because sensitivity play a role. Besides sensitivity, there are also risk limits, which we will see then in lecture 11. The next lecture, we talk about risk. Actually, that's the final step, which we are doing there. So you can do limits on risk. So if you don't have that, and often you don't have it, and often maybe you don't want it, so then you do sensitivity limits. And if you see that risk is exposure times volatility, and the exposure is also sensitivity. That is a synonym for sensitivity. So then if you take an exposure limit, the limit is then bigger as an exposure, like bigger than duration x, y, z, which is risk divided by volatility. So it's a risk measure of 1 unit volatility. That is what you measure with such sensitivity limits. So, and what you take as a technique, if you take interest rate, what kind of limit would you take? It's already up there. The gap plays, for example, an important role. So what you saw before, you know, these bars on the timeline. So they are heavily used. So that you use that as a limit system. Another one is like just pure sensitivity limits. You can have a duration limit, but this is one number, or FX exposure limit. Market exposure limit, you know, the different limits which you do. So, but for this, you have to know the sensitivities first. So you calculate the sensitivities, you have a limit, and the sensitivity should be inside that limit. Besides that, there are even other types, like simple volume limits. Often you have limits on book values. That's like very rough, but maybe better than nothing. Often if you have credit exposure, you do it on book value. Because there the book value and net present value is maybe not that too far away, and it's better than nothing. So, and the other one, the final one, is loss limits. So there you calculate the loss, and if the loss hits a certain thing, you do something. So that's a classical gap limit. The gap limit shows you how sensitive you are to each of these risk factors. That can be positive or negative. So then depends whether you are sensitive to upward or downward shifts. That is what it's saying. And you could draw a line like that, saying maybe in the short range you accept bigger gaps. Because why would you accept bigger ones? Because there the sensitivity is less. So it's even big movements there, they are not that harmful. But outside, far out, even if you have a small gap, because it's very sensitive, like a 5-year duration, so then it's every interest, 1% gives you a 5% change in value, so it becomes narrow to the end. So you make much more narrow gap limits in the long range than in the short range. So that's how it could look like. The last step yet before we are finished, and then I let you go, is limit setting itself. That is an art inside. So first we defined what kind of limit we want to have, like sensitivity limit, risk limit, and if sensitivity, a gap limit, a duration limit, etc. So we define what are we actually looking at, and then we need a system, so how big should the limit be? And limits are normally hierarchical. That means you have at lowest level certain limits, for example, per trader. So each trader gets a limit, or a department gets a limit. So if your loans is limited, like this and that. So you have at the low level, you have limits, and then you have higher level limits. Here, for example, at the higher level A, you have a limit of 1.8 million. And if you look at this at the lower level, if you add that up, you come 1.7, 2.3 actually. So why should you have a lower limit on the higher than on the smaller? It's due to correlation. That takes correlation into account. So that's why you accept lower limits. So it's not additive. So the correlation takes out some of the risk. And so that's why it goes up like this. And of course, you can not only give a limit on an institution, but you can give country limit, FX limits, and so on and so on. And banks have whole limit systems. So whenever you get close to such a limit, the bell should ring and somebody should do something, but often the limits are broken. Maybe not now. Now they are more careful, but let's say in 2007 the bell ringing doesn't matter. Let's wait, it's getting better again till it doesn't. Yeah, so much to sensitivity and limits. Any question? You will get it all out of the system here, especially those who do something with sensitivity and so on. Okay, thank you very much, and see you next week. Thank you.